1.7 Linear modeling scatter plots. What you should learn: construct scatter plots and interpret correlation. Use scatter plots in the graphing utility to find linear models. A scatter plot is just a way to display data, right? So many real life situations, you usually have a relationship between two variables, such as a year and the number of employees that the telecommunications industry is given here. And you're just going to put one for X, one for Y, and you're going to plot it and see what that tells you. And that's what we're going to do here. So that plot is called a scatter plot. And we like to do it with the calculator. We can do it by hand also, but let's do an example here. The data in the table shows the number of thousand of employees in the cellular industry in the United States from 2002 to 2007. Construct a scatter plot of the data. So first, I'm going to bring on the calculator. So the one I'm going to use in this class is a TI-84. So TI-84, very simple, very easy to use. First thing I'm going to do is turn it on right here. So there's our screen, all our buttons. We want to make a scatter plot. So first I got to enter in this data. So I'm going to go here to Stat, press that button. We have Edit. It's where you edit your data. You can sort. There's other things here. But first thing I'm going to do is enter in my data. So I'm going to go to Edit, press Enter. And then there's L1, L2, L3. I'm just going to write down L1. Usually, we don't want to put 2000, and we'll just put 2 to symbolize 2000. So I'm just going to put 2, then 3, then 4, 5, 6, and 7. So we'll use 2 for the year 2002. And then here we're going to use the number of employees. So 192, 206, 226, 233, 254, and 267. Just like that. So we enter in the data. Now we want to graph it. So up here is all like the graphing utilities. If I hit graph right now, you just get like a normal XY graph. But I want to see this data. So first thing I do is I can turn it on. So this is a stat plot we're doing. So you can see here in the blue it says stat plot. So to access that, you have to hit the blue button for a second, and then stat plot. And then right now they're all turned off. So I'm going to select the first one, and I'm going to turn it on first thing. And the next here is like what type of stat plot do you want? You could do like a scatter plot like we're doing now. You could do accumulation. You could do an accumulation graph, I believe that is. A bar graph, a Boston whisker graph, another accumulation graph, I think. Anyway, we'll just do our scatter plot. So I'm gonna go down and leave that alone. My X list, so where are my X values? Well, we use this for my X values. That was my L1. If you go back, that was L1. And my Y is L2. We'll usually leave it at that. And then you can also change the mark. So I'm gonna leave it at that. We're gonna hit enter, and then I'm gonna hit graph, and I'm still gonna see nothing because my window is off. Right? Look at my values here. The Y should go to like 192. This is like a basic window. Negative 10 to 10, negative 10 to 10. So there's two ways to fix this. Way one is go to window and fix it yourself. So my X values, let's go from like 0 to 10. And scale 1, that's what you want to count by. My Y values, let's go from 0 to like 300, maybe. Now if I hit graph, I should see some data there. And it looks like I mistyped something. Let me go in, because that definitely doesn't fit this. Let me go back. So second, you probably saw it before I did. Stat, edit. 26, it should be 226. There we go. 6. Now if I hit graph, it should be more correct. So that's our scatter plot. That's it. That's our scatter plot data. If I want you to show it on here, you can just draw it. Just do like a little blah, blah, blah. Looks kind of like that. That's what the scatter plot looks like. Next, let's talk about what this means, right? What does it mean that it looks like this? Well, it means a couple things, and let's talk about it. So first, the fact that it's going up, right, like a positive slope, means it's a positive correlation. If it was going down, it'll have a negative correlation. If it was kind of scattershot all over the place, it'll have no correlation. Positive correlation just means as the X goes up, so does the Y. So an example of that would be like studying, like our studying and your grades, right? Most of the time, the more you study, the higher your grade. Negative correlation B, as X goes up, Y would come down. That's not necessarily a bad thing. Something like the more you exercise, your weight would go down maybe. So negative correlation is something goes up, the other thing goes down. And then no correlation, these two things have no correlation at all. Like your height and your grades in the class, right? You could be tall, you could be short, it doesn't matter. So those are correlations. Okay, so let's interpret some correlation here. So we want to create a scatter plot for this data. So what's going on here is the number of hours they study for a test compared to the score on the test. That's what this first one is, right? So they say right here the first coordinate is the number of hours studying, so 0 hours, and the score on the test 40. Where this person here studied for 10 hours and got scored 98. And then vice versa, this is the number of hours watched TV and score on the test. So this person watched 0 TV and got 98. This person here got to watch 20 hours of TV and got a 40. So we want to plot this data. So let's go back to our calculator. Let's go to edit. I type in data, so stat, edit, and let's show you how to like rewrite this. So I have an x1, x2. So in this case, my L1 is going to be, let's do the first one, 0, right? So you can just you can write over it. That's one way to do it. If you just want to clear the whole thing out, the key thing you want to do here is don't put delete. Like you can delete an entry, that's no problem. But if you want to like clear a whole column, you don't want to hit delete. You want to hit clear. So you hit clear and then press enter. It clears the whole column. If you hit delete, like I'm going to do here just to show you, it just deletes the column, but now you don't have an L2. Now it's easy to get it back. You just go back to stat, and you put setup editor. That will set up the editor back to the way it was before. So you go setup editor, put yes, you go back to stat, edit, and it's back. But, so you want to clear, entry delete, you want to clear a column. So I'm going to type in all these letters, and I'll do it off camera so you don't waste time seeing me type in them. Okay, so I typed it in off camera, and I did L1, L2, L1 for hours, L2 for score, and then I actually went L3, L4 for the TV hours, just because I didn't want to like retype it all in. So I just did all at once. If I hit graph, it will kind of graph this first one, study hours. Now the window's not perfect because I didn't adjust the window. So you could go back to window and adjust it yourself and try to figure out the min and max. But here's another way. We're going to go to zoom, and I'm going to go down to zoom fit. Actually, no, not zoom fit. Zoom stats right here. So zoom stats, we'll look at the data we have, and we'll try to find the best window for our data. So type it in, and then there's our zoom stats right there. So there's our data. It looks like it's mostly, I might have typed some things in wrong, or did they, those are people that did okay. It looks like it's mostly a positive correlation, right? There's some outliers here. We'll eventually talk about outliers. Or I might have made a mistake in one of the two. Right now I only put in study hours. So let's see what the question says, right? Determine whether the points are positive correlated, negative correlated, or no correlation. I would say it's a positive correlation. So what it means is the more you study, in general, the higher you get, right? There's a couple of kids here that didn't study and got really low scores. And there's a kid here that didn't really study, but he got like the highest score on the test, which might be my typo. But in general, the more you study, the better you did. Now, I only put in studying hours. So I could also type in another stat plot. I could either rewrite this one or I could type a new one in. And in this case, I'm going to turn it on again. I'm going to go to L3 and L4. So, second L3, you can see here in blue. And then L4, second L4, right there. And I'm going to graph this one. You could change the mark if you want to make sure. And then now you can see it graphs like that. Now, that's kind of hard to see. What I'm going to do here is I'm going to go to stat plot, this like y equals. I'm going to turn off plot 1. I'm going to just go up there and select it. That's probably the easiest way to turn on a stat plot. You can also just do what we did before and go to stat plot and like go in and turn it off. But the easiest way I found is go to y equals and then just unselect it basically. If I hit graph now, you can see it's a little clearer, right? It's a negative correlation, right? In general, the more TV you watched, the less your score was. So positive correlation has a negative correlation. So that's this problem. Let's do a line of best fit. So we're gonna go back to the same data we had, and then this time we want to like make an equation out of our data, right? This was a positive correlation. We wanted to, like, if we could find an equation, then we could predict things. I could put it in a year, and I could figure out how many employees there are in the company. So we're gonna eventually do this with the calculator. This first one they want you to do by hand. So they just want you to plot the data. So sorry for my rudimentary graph here, but we're going to do the year 2 with 192. So like around there, I'm just going to do a very sketchy graph. I don't have a perfect graph here. 192, 3 is 206. So around there. Again, it's not going to be a perfect graph. I didn't think ahead. 4 is 226. I got to move a point already. So I can move that one to here. 192. There we go. 5 is 233. So around there. Again, it's not going to be a perfect graph. 6 is 254. So up here. And then 7 is 267. So around there. So a line of best fit, you want to try to draw a line here that kind of goes, you're not trying to hit all the points, that's not going to happen, but you're trying to like kind of go in between all the points. So it's a line of best fit, something to like this effect. So something that's going to kind of like go between the points, let's say like around there. Right, that's like my line of best fit. And then what you want to do is try to find two points. They could cross you could use a points that cross if you want to. But in general, you're trying to find just 2 points that look like they kind of cross nicely. So let's say 2 and 200. We're just going to estimate 2 and 200. Just make my life easy. and then we'll say 6 and 250. We'll say it's 6 and 250. And we want to make an equation of a line out of that, right? Y minus y1 equals m x minus x1. Right? And so the same way we did it in section 1, we have to find the slope, and then we're going to plug a point in, right? So find my slope, y2 minus y1 over x2 minus x1. This would be y2 and x1, x2 y2, x1 y1. I don't know why I made that so complicated. So we're going to do 250 minus 200 over 6 minus 2. So we're going to get 50 over 4, 25 over 2, so about 12.5 is my slope. And then my equation here is going to be 2 and 200, so we'll put 2 here and 200 there. And I usually want to put this in slope-intercept form, so like distribute, I get y minus 200 equals, let's say 12.5 x minus 25, and then plus 200, plus 200. And my line of best fit is this, 12.5 x plus 175. And again, what does that mean? Remember my x was the year, so this is years. And my y is the number of employees. So if I want to figure out how many employees there are in the year 2010, I'll just substitute 10 in for x, and then I get my answer. Right? If I want to figure out when we're going to have like 300,000 employees, you plug in 300 into here, right? Because it's in thousands. Yeah. So you plug 300 into here, and then you can figure out in what year you have the 300 employees. So having an equation is a very important tool. And knowing how to make one is very important, right? So to do it by hand, we just got to plot the data, draw a line of best fit, and then find the equation line like you always find the equation line, right? Slope-intercept, or you can do this way or slope-intercept form. Basically find the slope, find a point, plug it in, and simplify. Okay, now let's all deal with the calculator. Actually, let's do it on here with the calculator. I think I have the data typed in. So let me show you the calculator version. So data's all typed in. We're going to go back to graph it. So I'm going to go back to my stat plot. Sorry, no technical difficulties. Let's go back to our stat plot. I'm going to turn that one back on. Let's turn the other one off. So stat plot, right, because this is from the previous problem. Okay, so the one I want is on. L1, L2, I already typed it all in there. I don't see anything because remember, I haven't fixed my window yet. So let's go zoom stat. I believe that's 9. You can either go down or you can just press 9. So there's my data. The way you do a line of best fit, it's called a linear regression on a calculator, is we're going to go to stat. We're going to go over here to calculate. And we're going to pick the linear regression. So number 4, linear regression. So it says L1, L2. Frequency list, we do not have a frequency list. Sometimes this is a frequency. We don't have that. Store regression equation. So you actually store it. It's like a pro move. So we're going to do this real quick. You don't have to. Actually, let's do it. Let's not do it. And I'll show you what happens if we do it. And then just calculate, right? So it's going to say, hey, that's your L1, that's your L2, that's my X and Y. And then there's no frequency, so leave that blank. And then we're going to calculate. So it's going to calculate its line of best fit. And it found Y equals 15x plus 162. Not too bad from what I got, right? I just did that on a rudimentary graph, and I got pretty close to what the calculator found to find the best line of best fit. Now, if I go to graph here, right, you don't see anything. Let's go back to the thing we just did. I'm going to go second. I should just go stat. I don't know why I put second. Just go stat, go to calculator. We're going to go back to our linear regression. This time we're going to do it the pro way. L1, L2. We have a frequency list. I'm going to leave that blank. I don't know why I highlighted that. We have store regression equation. That's what I want to do. Let's do the store regression equation. So the easiest way to do this, I want to type this in for right here. This is my y equals. This is my graphs. Like you graph mx plus b, x plus 5. I want to graph the regression equation. So we're going to go up to my stat, back to calculator. Easiest way to do this is you go here, and we're going to press alpha F4, and it brings up all the y values. So I'll put y1, then I'm going to say calculate. And what it's going to do, it's going to calculate this equation. I'll put it in here for y1. See right there? Now when I hit graph, it's also going to graph that equation. And you can see the line of best. Now the one thing we haven't talked about is how good of a correlation is this? How well does it fit the data? And we actually do something in our calculator. Because at first, when we got our stuff here, it doesn't say anything. So by default, we should actually, not by default, we actually want to turn on a correlation coefficient, which tells us how closely our data is correlated. So to do that, we have to go to mode, because by default it's turned off. So you're going to go to mode here. Toward the bottom, there's something that says stat diagnosis. And by default it's turned off. I don't know why. Let's turn it on. Right, I'm going to go back to our correlation. So the easiest way to do it is just press up on here. You go up, you go back to your previous work. I'm just going to highlight one of these. Press enter. And to recalculate it, and then you're going to notice, oh, I have to press enter. There you go. It has an R and R squared values here, right? These are the correlation coefficients. So R lets you know how closely the data is related. The closer to 1 you are, the more positively close related it is. The closer to -1 you are, the more negatively closer correlated you are. If it's close to 0, that means it's not related at all. There's no correlation. So this one's a very strong correlation of almost 1. So we had a strong correlation there. And that's the lesson.